All right, pick up where we left off, 3.2 notes number 9. So we're going to start with this cotangent function. So think about that as cosine of theta over sine of theta. And why we're interested in that is when this equals 0, then our cotangent function is going to be undefined or have those asymptotes. So let's get our axes on here. And I'm going to make a note of this. This is telling us that vertical shift. So we need to move our axis that has theta on it down, if I could draw a straight line maybe, down 2. That's going to be our new axis with theta on it. And I also want to put a little tick mark there because that's going to help me graph my ghost function, the sine function here. Next thing we want to look at is if I was graphing a sine function, what would our period be? So that would be 2 pi, but our b value is 1/2. So I got to divide this by 1/2. So I do 2 pi times 2 over 1 or 4 pi. So I'm going to use that 4 pi to label my tick marks. Now, I don't have to worry about a phase shift because we've already looked at this equation and said there is no phase shifts. So I've got those on there. Now, the next thing that I want to do is graph my ghost function, which would be the sine. So sine starts at 0, up, back to 0, down, back to 0. Now, anywhere that the sine is on our new axis here, we want to put an asymptote. That's going to make this fraction be undefined. Yay. All right, next thing we want to look at is it's a cotangent function. So it starts up at the top left and then goes down and approaches that other asymptote. And it looks like those negative x cubed graphs that we've worked with like in Algebra 2. Okay, I don't like that one. There we go. I'm not the best drawer of those little curves, but I do want you to look at this in terms of amplitude because it does ask for that. It doesn't have one on our cotangent function. Period is going to be half of what the sine or cosine function would be. So if we were at 4 pi, this would be 2 pi. And we said there was a vertical shift, so we're going to write that, and I like to write it as down 2, so I remember to move everything down 2. Last but not least is think about this in terms of that period, right? This should be repeating. You don't have to draw this, but I wanted you guys to notice this. I have an asymptote here, and I have an asymptote beginning again at 2 pi, or starting over, or showing up again. And really, that's that for that one. All right, looking at number 10, we're talking about a secant graph. So in terms of looking for a ghost function or where those asymptotes are going to be, we want to think about that as being 1 over cosine. So again, when this is equal to 0, then our secant function is going to be undefined. So let's get this axis set up. Couple things that we want to do though is we want to keep looking at this 2 because that's going to help us figure out where our cosine function is going to go. Other things is we want to figure out our period, which is going to be the same as our cosine or our sine functions would be. So I would take 2 pi divided by our b value, which is 1. So that comes out to be 2 pi. We also have a phase shift in here, and how I know that is because we have some theta value that's going to shift all the theta values one way or the other. So I want to take that theta plus pi over 4, again like we did in chapter 2, and move the pi over 4. This gives us our phase shift, which is negative pi over 4. Make a note, that's moving to the left, so we make sure that we have room to the left. There's no vertical shift, so we don't have to worry about that, which is great news as well. So I'm going to get 2 pi on here, and I'm going to probably go pretty darn close to the end. And we know how to break these up. We've done it so many times. All right, the other thing, remember, our cosine graph would be using these 2. Our secant graph won't be using those as its high and low, but it's going to help us determine where all those go. Let's see, we have, oh, our phase shift. We got to get that on there. Remember, our phase shift is pi over 4, but it's negative. So I want negative pi over 2 here because pi over 4 has to be between 0 and negative pi over 2. That's where this would fall, in between there. So I got to move our axis line right in between 0 and negative pi over 2. I think I'm ready to graph now. There's nothing else that we're missing, so let's get some points on there. Remember, we want cosine graph. Cosine graph starts up top. Think in between. So to 0, then down low, in between, in between. So now if you think about doing your little dotted line here for the curve, if my smartboard was better, we wouldn't have all these issues, but it's not. So now anywhere that you see this on the x-axis or being 0, that's where we have to have our asymptotes. So right here and right here. And the nice thing about this, remember, is that the secant function shares this point, but flips up, shares this point, and this one flips down, shares this point and flips up. And again, this is your graph with our phase shift of negative pi over 4, no vertical shifts, still a period of 2 pi, and that one is actually complete as well. All right, let's talk number 11. We're looking at this and we're seeing this cosecant, so you want to be thinking 1 over sine. Now, when this equals 0 again, our cosecant graph is going to be undefined. There's lots of other things going on. Remember this 1 I could put over here as +1, so just keep that in mind. Maybe do that in your head if that helps. That represents our vertical shift, so let's make note of that. We're going up 1 for our vertical. So let's start with our x and y axes on here, and then we can at least get that new axis. So here is our axis, and we're going to move that up 1. All right, next thing that we want to do is we want to look at what our different things are that's going on here. First thing is when we're graphing a sine function, we work with 2 pi. Same kind of thing here with the cosecant. And we divide by our b value. Our b value is 2. So this is going to give us pi. So our period is pi. Why did I start there? Because I want us to work through that. The next thing that we want to look through is our phase shift. We're going to set our parentheses equal to 0. So 2 theta minus pi over 4 equals 0. You should be able to move the pi over 4 by adding it. And then I'm going to multiply by 1 over 2. So I don't have to do some crazy thing with my calculator and put pi in and then it looks all gross. So our phase shift is to the right, pi over 8. All right, one other thing that you want to keep in mind, we've talked about period, we've talked about phase shift, we also did vertical shift. When we're graphing our sine function, we want to go up 3 or down 3. So I'm going to put that on here. 1, 2, 3. 1, 2, 3. 3, not 3 as the value, but 3 up from our new axis. Make sure you have those on there. Next thing we got to do is we have to do our period. So I'm going to put that on here. And I'm going to leave a little bit of room because we're moving to the right with our phase shift. So our period's pi, we're going to cut that in half. We're going to cut that in half again. And we have to figure out that last increment here. And if you're not sure, you should probably do some counting. 1 pi over 4, 2 pi over 4, 3 pi over 4. And remember, whatever you put here has to be less than that pi value. Next thing is figuring out where pi over 8 is. Pi over 8 is less than pi over 4. So we need one more increment to the right. This would be 4 pi over 4, so 5 pi over 4. And then we're going to move our axis. Here's our axis. And really all we're moving that is less, it's technically halfway between. So maybe make yourself a note so that makes sense to you when you look back at this. This guy is going to be between this one will be between, 0 and pi over 4, right in between when we do our phase shift. So I move that over. All right, let's get graphing our ghost function. Our ghost function we said was sine. So we're here, then we go up, in between, back to 0, in between again. We go down, in between, back to 0. Again, in between. So now that we've got our ghost function, and I will try to make this dotted, but for some reason this board does not like me doing dotted. Anywhere that this is on this blue line here, we're going to have, anywhere those points for sine is on here, we're going to have our asymptotes. So there will be an asymptote here. There will be an asymptote here. See, it does not like dotted lines. I hate it. I'll go slower. All right, now when we graph, finishing this off, our cosecant function, we will have share of points here and approach those asymptotes. Share of points here and be flipped down and approach those asymptotes. All right, so let's take a look at number 12. This one is a tangent function. One thing you have to remember about the tangent function is that we are working with sine over cosine. So when this equals 0, then our tangent function is going to be undefined. So let me get our x and y axes on here, and then we can do some adjustments. The first thing I want you to notice, and this will help you to get this on here without a ton of trouble, is doing our vertical shift, which is down 1. So we're going to take that and we're going to move it down 1, if I can get this to work. So move that axis where your thetas will be, of course, down 1. Then the other thing that you want to take into consideration, and this really only is an issue when you are graphing our ghost function, is that 3. So I want 1, 2, 3 above and 1, 2, 3 below. That really doesn't affect our tangent function because remember our tangent function amplitude is non-applicable because it keeps on going off into positive and negative infinity. So we've taken that into consideration. The next thing that we want to do is we want to figure out how am I going to graph this ghost function. So I have that 2 pi still for the cosine function, and I'm going to divide by our b value, which is 2. So that gives me pi as our period for our ghost function. So I'm going to start with that, and I'll break that up as we've done multiple times before. Then the other thing that we want to look at is our phase shift. So we're going to set, for our phase shift, we're going to set our parentheses equal to 0. When we set that equal to 0, I move the pi over, or the 3 pi over 4 to the other side, and then I'm going to multiply by 1/2 on each side. So I can get rid of that 2 next to theta. So now that's 3 pi over 8. So our phase shift is 3 pi over 8. Remember, that's going to the right. And now I want to figure out where that is so I can find my new axis line here. Where is that going to move? Well, if I do 3 divided by 8, I get the 0.375. So 0.375 pi. Well, where is that going to land in terms of how we have our increments labeled here? So for that, think about what does this pi over 2, that is 0.5. This is 0.25. So it's got to be between pi over 4 and pi over 2, somewhere in between there. So I'm going to take this and I'm going to move my axis in between pi over 4 and pi over 2. So that means in accordance with labeling our increments or our tick marks, I want to put on 2 more just so we can complete this graph. Remember, we're counting by pi over 4. So we're at 3 pi over 4, 4 pi over 4, 5 pi over 4, and 6 pi over 4, which simplifies the 3 pi over 2. So now that I have this, I want to graph my ghost function, which is the cosine one. And that's, again, we're really looking for the values when cosine is 0, because that's where the asymptotes will be. So for our cosine function, we always start up top. And then remember, that's in between our 2 tick marks here and here. So the next point's going to be in between as well, but it'll be on our new access point. And then in between, and in between. So the only ones that I'm really concerned about now are when the cosine was 0, back on that axis. So this guy is where our asymptote's going to be. This one is where our other asymptote will be. Then after we've got that, then we want to fill in with our tangent function. So remember what our tangent function looks like. It's a positive tangent function, so it's going to approach this asymptote. And it's going to approach this asymptote. And then we have a value in here as well that's approaching this asymptote. Okay, and if you wanted to get even more crazy and add maybe another asymptote in here just so you can kind of finish this off, keep in mind the pattern that's going here. We have a 0, an asymptote, a 0, an asymptote. So there would technically be another asymptote here, okay? And that kind of matches what we have. The other things that you might want to list just to kind of finish this off here is we do have our phase shifts, okay? We have our amplitude, which was non-applicable. Remember, we talk about our period, and in terms of a tangent function is really half of what the cosine function is, or the sine function. So our period is technically pi over 2. And then if we were listing our vertical shift, we would say down 1. And those were the other things that you should probably include.